So in this video, I'm going to talk about how different solvents can affect an SN2 reaction. And so solvents can be classified as polar or nonpolar, and protic or aprotic. And so polar versus nonpolar, obviously, it's just talking about the distribution of electrons and if you have an overall dipole moment, while protic and aprotic is essentially just referring to whether the molecule has acidic protons. And so first, let's kind of compare protic versus aprotic. So protic solvents have acidic protons, and so these are usually an OH or an NH. Let me draw you some examples. And we're going to be essentially focused on alcohols and hydrogens bonded to nitrogen. So as you can see below, I've given some examples. Water, for example, has an acidic proton, and any alcohols are also going to have an acidic proton. Something else, such as a hydrogen bonded to nitrogen, will also have an acidic proton. And this is going to contrast with the aprotic solvents because the aprotic solvents have no OHs or NH protons. And so let me draw some examples. And so as you can see, you have an ether. And I drew these a little differently. I drew them as this because I didn't want to draw out all of the hydrogens, but we know that they're implied. So we have ethers, acetones, and a molecule that's referred to as DMF. And so as you can see, all of these molecules, they don't have an OH or an NH proton. So as a result, they're referred to as being aprotic due to the fact that hydrogens or protons are very hard to remove. And so if you have a solvent of something that's protic, you're going to have a lot of hydrogens floating around in the solvent, while something that's aprotic, you're going to have much less hydrogens or protons floating around in the solvent. And that's going to affect the reaction rate, which we'll talk about in the future. And now we have to compare polar versus nonpolar. And so, as you can see, polar versus nonpolar, a polar molecule is going to have an uneven distribution of electrons. And so what that means is that one atom in a bond is going to be pulling electrons a lot more than another. And so oxygen is a lot more electronegative than carbon. And so that oxygen is going to be a lot more negative. So you could draw a partial negative there and a partial positive on the carbon. And on the side of nonpolar, you have hexanes, CCl4, as well as benzene. And a good way to roughly measure polarity is called a dielectric constant. And so generally, a dielectric constant of under 15 implies that it's nonpolar, and if it's greater than 15, it's polar. And so let's think about what this means when we're talking about SN2 reactions. So SN2 reactions, and any reaction really, needs a solvent for it to occur in. And so everything essentially depends on what nucleophile you have versus what solvent you have. And let's talk about an example, for example. So we're going to use a nucleophile OH and then put it in two different solvents. And you can try and decide which one you think would work better. So as we know, acetone is a polar aprotic solvent, while water is polar protic. And so as we talked about before, protic and aprotic essentially differ in the amount of hydrogens available in the solution. And we also have to remember what occurs with hydrogen bonding. And so in a polar protic solvent such as water, the negative oxygen on the OH minus is going to be attracted to that hydrogen. And essentially what's going to occur is there's going to be hydrogen bonding. So hydrogen bonding occurs between polar protic solvents. This slows down the Sn2 reaction, and essentially it takes up a lot of the nucleophile, and in order for the Sn2 reaction to take place, this intermolecular force has to be broken. And so, as you can imagine, that would take a lot more effort and it wouldn't be ideal. While in a polar aprotic, such as acetone, the nucleophile is not strongly solvated, and so as a result, it's free to partake in its reaction, and you essentially have more OH minuses available to participate in the Sn2 reactions. And so furthermore, we have to determine whether a polar molecule versus a nonpolar molecule, which one would be better. Well, in this case, I'm just going to tell you a polar molecule is a lot better for Sn2 reactions because we have to remember the transition state of the Sn2 reaction, where one side of the molecule with the nucleophile is going to be partially negative, while the other side with the leaving group is also going to be partially negative. And so as a result, you want to essentially stabilize that transition state. And so if you have a polar molecule, you can dissolve the nucleophile and stabilize its transition state. And so let me just conclude and write down all of the important things that you have to take from this video. Polar protic solvents will form a shell around the nucleophile. And what that does is it makes it a lot harder for collisions to occur and for the reactions to be productive, because we know that the nucleophile has to come into contact with the electrophile in order for the Sn2 reaction to occur. Now, if you have a whole bunch of stuff essentially formed a shell around the nucleophile, that reaction is going to be less likely to occur. And protic solvents form strong intermolecular forces, and this is bad because that has to be broken in order for the Sn2 reaction to occur. And so the most important thing that I think you need to take out of this video is that for Sn2 reactions, polar aprotic solvents are the best. And you want it to be polar in order for the solvent to stabilize the transition state of the Sn2 reaction. And you want it to be aprotic because you don't want the intermolecular forces, which are the hydrogen bonds that need to be broken before an Sn2 reaction can occur. If you don't have, and remember that would be coming from protic solvents. So protic solvents would give you the hydrogen bonds. And so you don't want that because in order for an Sn2 reaction to occur, the hydrogen bonds must be broken first, and that's just an extra step that's not needed. And so aprotic solvents do not have those, and as a result, that's going to be the best solvent. So I hope this video helped you. If it did, please give it a like and share it with your friends.